Dear students, observe the question. Let f from R to R be a function. We say that f has a property 1. If limit h tends to 0, f of h minus f of 0 by root mod h exists and is finite. And property 2. If limit h tends to 0, f of h minus f of 0 by h square exists and is finite. Then which of the following options are correct? The first option, f of x is equal to x mod x, has the property 2. Second option, f of x is equal to x power 2 by 3, has the property 1. And third option, f of x is equal to sin x, has the property 2. And fourth option, f of x is equal to mod x, has the property 1. Okay, actually this is the question from JEE-ADVANCED 2019 from paper 2, from first section. This is more than one option type question. Okay. Now from the given question construction, there exist two properties, and from the options there are some examples according to the properties. So we have to verify the options from the both the property 1 and 2. Okay, now we have to solve the question. Solution for this one. Now from first option, from option 1. So what is that? This is f of x is equal to x mod x. This goes to the property 2. What is the property 2? That is limit h tends to 0, f of h minus f of 0 by h square. Actually, what is f of h? That means limit h tends to 0, f of h mod h, right? F of 0, it is 0 by h square. Now here, limit h tends to 0, h mod h by h square. It gives 2, that means left neighborhood of 0 and right neighborhood of 0. Two limits, it's split into two limits. That is limit h tends to 0 minus. For h tends to 0 minus means h less than 0. If h less than 0, this is minus h. Then it is minus h square by h square. That is minus 1. Okay. Now for this one. Now limit h tends to 0 plus. 0 plus means h greater than 0. Right neighborhood. Then it is h square by h square. It is 1. That's why LHL not equal to RHL. That's why it does not exist. This is does not exist. Limit that means f of that means limit h tends to 0. F of h is does not exist. Is not exist. Does not exist. Since this is both the properties exist and finite, but this is does not exist. That's why first option is wrong. Right. Now we are going to second option. Now from second option, from option 2, what is that option 2? F of x is equal to x power 2 by 3. That is from property 1. So take the property, that is limit h tends to 0, f of h minus f of 0 by root h. F of h minus f of 0 by root h. So that is mistake. F of h minus f of 0 by root h. That's all. Now we have to write limit root mod h, that is, right? So root mod h. Now limit h tends to 0, f of h, that is h power 2 by 3, f of 0 is 0 by root mod h is nothing but h power 1 by 2. That's why it gives, what is this? H power 1 by 2 means h power 2 by 3 minus 1 by 2. H power 2 by 3 minus 1 by 2 is nothing but 1 by 6. H power 2 by 3 minus 1 by 2 is 2 by 6. That's why h power 1 by 6. That's why it is positive. It gives 0. That's why belongs to R. It is exist. That's why the second option is also exist. Exist. Since required exist and finite. That's why 0 is finite. Finite number. Belongs to real number set. That's all. Now from option 3. From third option we have to take. From third option. What is third option? F of x is equal to sin x. That is from second property. What is that? Limit h tends to 0, f of h minus f of 0 by h square. That is limit h tends to 0, f of h sin h minus f of 0 sin 0 is 0. That's all by h square. Actually we know that limit h tends to 0 sin h by h is 1 into limit h tends to 0 1 by h. So limit h tends to 0 sin h by h is 1. It is exist, but it is does not exist. It is infinity, infinite, but require finite. Here it is infinite. That's why this is not satisfied. That is not correct. Now verify the fourth option. From option 4. What is that? F of x is equal to mod x. F of x is equal to mod x. That is from property 1. Limit h tends to 0, f of h minus f of 0 by root mod h. Right? Substitute that. So f of h is mod h by root mod h. Root mod h. Limit h tends to 0. Limit h tends to 0, mod h by root mod h. Okay. So mod h is h, root mod h is h per 1 by 2. That means limit h tends to 0, h by root h. That means h for 1 by 2 is root h. So root h is 0. That's all. 0. It is finite. It is also finite. Exist and finite. So from first option limit is does not exist. From second option limit is exist and finite value 0. From third option limit is does not exist since limit is exist but infinite value. Here it is limit is exist and finite value, that is 0. That's why fourth option is correct. That's why second option, fourth option correct according to the properties, and first option, third option wrong. That's all. Okay, right.